Hi everyone, this is Paolo Tezzon and I am the Research and Development Manager for Diapason Loudspeakers, Brescia, Italy. And I'm very happy to welcome all of you into this series of short video clips which are about technical insights when it comes to our latest creation, the Didascalia speakers that you can see behind me. Didascalia has been introduced into the market and the official launch was happening last fall in October 2025 at the Warsaw Audio Video Show. Therefore, it's a brand new design and it represents a huge milestone in the history of the Diapason brand. Because with this design we wanted to mark a statement, to mark even a manifesto about the future of the brand. So we came up with a crazy design. In the previous episodes we were already digging into the details relative to the tweeter and to the front-firing mid-woofer as well, which, this is also important to underline once again, are 100% a Diapason design. They have been conceived and designed here in Brescia, Italy, in cooperation and with the technical support of Scanspeak, Denmark. So, I highly recommend you, before moving forward in watching this video, to go back to the episode 1 and the episode 2, so that you have already an understanding of both the tweeter and the mid-woofer. Today we are discussing the third element when it comes to the speakers we developed for Didascalia, which is the craziest one. You can see it here in my hand. It's a pretty unconventional speaker. Is playing a pretty unconventional role, and it has a pretty unconventional shape as well. In fact, this loudspeaker is a racetrack-shaped speaker, which is size-wise can be compared to something which doesn't really exist in nature, because it's something in between an 8-inch and a 10-inch speaker. So it could be defined as a 9-inch or as a 24-centimeter if we were talking about a circular loudspeaker. Well, we're not. This shape is coming straight from the late 70s, when a famous company, a famous British company, introduced such a design for the very first time. Then this design has been used not only by CAF, which is the British company who launched for the very first time a speaker with this kind of shape, the famous B139, but it's been used also by other companies, both coming from Italy and from Switzerland. We were talking about an unconventional shape, but also an unconventional role, because this speaker, when it comes to Didascalia, it is not connected to the signal. So this speaker is not fed by the amplifier, no matter it has a pretty impressive and pretty well-designed ceramic magnet system. Why so? In order to properly explain the reason why of this extravagant choice, we need to make you understand the design goal we set to ourselves when designing Didascalia. We wanted with Didascalia to overcome the typical limitations which are affecting any two-way design loudspeaker system. The two-way design is a design which is capable of some amazing performance when it comes to immediacy, when it comes to transparency, when it comes to phase coherence, because you have just one crossover point and only two drivers working. Therefore, the two-way proved itself being the best choice when it comes to conveying all the emotion, all the immediacy, all the feel available in a high-quality music reproduction. On the other hand, the two-way design typically comes with some limitations, which are due to the fact it is not capable to extend properly in the lower frequencies due to the size and to the small amount of drivers. Other limitations of a two-way design are the size, because it's very difficult to make a two-way design sound big. Actually, with Didascalia we wanted to overcome all those limitations. So having all the benefits of a two-way design, but not to having the downside of such a configuration. Therefore, we came up with some weird ideas. For instance, just to mention, in order to overcome the problem of the size and making Didascalia sound big, we came up with this construction, and the side wings have this surface which is loading the emission of the transducers, helping the Didascalia to sound way bigger than what it actually is. When it comes to overcome the other limitation, the extension in the bass, this weird baby comes to playing a very important role, because two of them are sharing the same enclosure together with the front-firing mid-woofer, and they are pressurized by the excursion performed by the mid-woofer itself. Of course, they've been calculated in both compliance, moving mass, in relationship with the TL small parameters of the front-firing mid-woofer, and in relation with the overall loading volume of the enclosure, in order to enhance the extension in the bass. And with this idea, providing a very wide emitting surface which can be easily and efficiently pressurized by the front-firing mid-woofer, we were able to reach the remarkable result of having a two-way design which is capable to extend down to 35 Hz, basically overcoming completely the typical limitation of a two-way design based on a 6.5/7-inch front-firing mid-woofer. The construction of this amazing transducer is based on a flat sandwich diaphragm, which is extremely stiff and extremely lightweight at the same time, because when it comes to reproduce properly the low frequency, you need a very effective pistonic behavior on one hand, but when it comes to the specific application, you need a reasonably light diaphragm, so that the pressure created by internally by the mid-woofer can be effectively put in motion such a device. It is built around CNC machine frame or basket. I wouldn't call it basket exactly, let's call it chassis, maybe it's better, simply because there are no OEM basket or chassis available for such a shape. But this allowed us to come up with state-of-the-art design, because we have two layers of CNC anodized avian aluminum coupled together by those small columns of brass. And the two materials, when coupled together, are a very good thing, because each material has a specific resonance frequency which has the tendency to be erased when coupled with the resonance frequency of the other material. Another important instance in design is that in order to have a very controlled pistonic behavior, this design is equipped with two different spiders with a different compliance in order to optimize the excursion. Last detail when it comes to the driver itself is about the fact that it will be a platform for the incoming diapason design. Therefore, there is inside of the voice coil a very specific area where you can add an extra mass when required in order to tune the behavior of such a driver of different implementation in the future. And again, Didascalia proved itself not only being an ambitious design, but also being a laboratory which allowed Diapason to come up with technical solutions which will define the future design of the brand. Another interesting solution we came up with when it comes to the bass reproduction, and this relative to the passive radiators, is something you can see over there. This is the back of the Didascalia, is CNC aluminum, and this detail which I'm showing you gives me also the chance to let you understand that the cabinet of the Didascalia has been enhanced with an exoskeleton made of CNC aluminum parts which are surrounding the main cabinetry in order to have the best possible ratio between stiffness and dampening. But in this particular case, I'm showing you this detail because of this knob. This knob is connected to a resistor, and it is connected to the left and right passive drone diaphragms, because no matter they are not connected to the signal, no matter they're not fed by the amplifier signal, they have, you might have noticed, a magnet. And the fact they have a magnet allows us to manage the excursion and the dampening of the excursion of the drone cones simply by short-circuiting the drivers themselves. Therefore, you can choose by 3 different dampening solution when it comes to Didascalia bass performance. And this is beautiful because with such a tool you can adapt the Didascalia performance to any given listening environment or to any taste when it comes to bass reproduction. The bass can be set in 3 different levels. With the open level, the 2 side-firing passive units are completely free to move. Going the opposite side, they are completely damped, and this allows to have a behavior which is pretty close to the seal design. And then we have something in between where the voice coil of the 2 passive units is short-circuited by a high-power resistor which is mounted over there for heat dissipation. Of course, you're never gonna reach the heat requiring such an amount of dissipation, but it was a nice idea to be safe and to come up with such a design implementation. Thank you very much for your attention. See you in the next episode of the Didascalia Technical Insight, and thank you very much. Goodbye, everybody.